Hello everyone, welcome to my channel. Today we are going to study integration by parts. Now here integration by parts is same as the multiplication rule that you have studied in the differentiation. Okay. Similarly here also we are going to study how to integrate the two functions which are getting multiplied. Okay, so here we have the two functions. The two functions are u and v. If you can see, this is u, this is v. Okay, and these two functions are getting multiplied and we have to integrate it. So the formula here is you have to keep u as it is, then integrate v minus, then you have to integrate, but inside we have the two things. First we have to derivate your u function, and then again you have to integrate v. After doing this you have to multiply both of these two terms and then you have to apply the integration. Okay, this is the rule. Now what are the rules for choosing the first and the second functions? That whenever you have been given with the question, how we will choose what will be the u and what will be the v? Okay, so for that we are going to use this rule. The first rule is the functions are selected in the serial order of the letters of the word liate. Now what is this liate? Liate means the L stands for the logarithmic function, I stands for the inverse trigonometric function, A stands for the algebraic function, T stands for the trigonometric function, and E stands for exponential function. Okay, so we have to choose it in the serial order of the letters of the word liate. Okay, so whenever the two functions will be given in the form of a multiplication, you have to identify which of the two functions has been given, and according to the serial orders of this you have to choose u as well as the v. This is the first rule. If you haven't understood this first rule, we are going to do the example, so in that case you will be able to identify clearly what will be the first and what will be the second function. Okay, now the rule number 2. The rule number 2 is if the integrand contains the logarithmic or an inverse trigonometric function. If your question contains your logarithmic as well as the inverse trigonometric function, take it as the first function. Okay, so you have to take it as a first function whether it is given as logarithmic or it is given as inverse trigonometric function. And in all such cases, if the second function is not given, okay, so in that case you have to take it as 1. Okay, so consider that the number 1 is present there and you have to treat it number 1 as a second function. Okay, okay, now I understand that this rule number 2 is also not been understood by you, but we'll do the questions and you will be able to understand. Okay, now we'll do the first question here where we have I is equal to integration e raised to 2x multiplied by cos 3x. Okay, now I'll just highlight here what are the two functions that we have. Okay, so in that case here this is your exponential function. Okay, and this is your trigonometric function. Now according to liate, if you see, the trigo term come first and then comes the exponential function. So in that case trigo term should be u and e term should be v. So here first of all what you have to take as u, you have to take trigo term, that is this term as u and this term as v. So this is your first function and this is your second function. Hope you understood how to identify this, the serial order. Okay, now we'll solve this and let's just see what we get. Okay, so here applying the same formula. Okay, so keeping u outside first, so cos 3x integration of v, that is e raised to 2x dx minus, then integration, but you have to take the derivative of u, that is derivative of cos 3x, and then again you have to repeat the integration of v, that is integration of e raised to 2x dx. Close the bracket and you have to write the dx. This dx stands for this integral. Okay, now cos 3x will remain as it is and integration of e raised to 2x will be e raised to 2x divided by the coefficient of x. Okay, minus integration. Now the derivative of cos 3x is minus sine 3x, and the derivative of 3x is 3. Okay, then integration of e raised to 2x is e raised to 2x upon 2, then dx. Okay, so we have evaluated the first integral, then we have multiplied with the derivative, and this is your resulting function. Again we have to integrate this. Then this cos 3x e raised to 2x upon 2, the minus and minus will become plus. We can take this 3 upon 2 outside. So now we left with e raised to 2x sine 3x dx. Okay, again you have the two functions which are getting multiplied. First is your exponential function, second your trigonometric function. Again, according to the LIATE rule, if you see, first trigoterm should be taken as u. Okay, this trigoterm should be taken as u, and this exponential term should be taken as v. The thing is, we have to apply the integration by parts formula again, because we have got the question as the product of these two function. Okay, so now we will write this again. Cos 3x multiplied by e raised to 2x upon 2 plus 3 by 2. Again we will apply the by parts formula. So keeping u aside, integration of v, I'll just integration of v dx minus again the integration, then the differentiation of u, that is sine 3x. Again you have to integrate v, close the bracket, then dx. Now this whole thing is getting multiplied with 3 by 2, so we will draw the bracket here. Okay, again we'll write this plus 3 by 2. We'll solve the bracket now. Now sine 3x will remain as it is, e raised to 2x, integration e raised to 2x will be e raised to 2x upon 2 minus again integration, derivative of sine. Derivative of sine is cos 3x, and the derivative of 3x will be 3. Okay, and again the integration of e raised to 2x will be e raised to 2x upon 2, then dx. Close the bracket. So we have our arrive here. Now what we can do, we will multiply this 3 by 2, this 3 by 2, both of these two terms. Okay, so I is equal to cos 3x e raised to 2x upon 2. Now we'll multiply this 3 by 2 inside, so that becomes 3 by 2 multiplied by sine 3x e raised to 2x upon 2, that will give you 3 by 4. 3 by 4 sine 3x multiplied by e raised to 2x. Now this 3 by 2 will also multiply to the third term. Okay, so that will be 3 by 2, and this 2 will be multiplied, so 3 by 4, and also we have here 3, so 3 by 2, 3 by 2 will become 9 by 4 with the minus sign. 9 by 4 integration cos 3x e raised to 2x dx. Now if you can just check, this term is your nothing but the question itself that was given, so we can substitute I here. Okay, so we'll write 9 by 4 I and plus c, and this whole thing will be repeated, so I'll just write it like this, plus 3 by 4 e raised to 2x sine 3x. Now this minus 9 by 4 will come on the left side, that becomes plus, so I plus 9 by 4 I will be equal to, and from these two terms we will take common. What common we have? E raised to 2x upon 2 we have, so we can take, and what we left with, cos 3x plus 3 by 2. Okay, and sine 3x. Okay, right. Now we'll solve this. 1 plus 9 by 4 will give you 13 by 4 I is equal to e raised to 2x again, and this whole thing will be repeated. 3 by 2 sine 3x. Also do not forget the constant c. Okay, now this 13 by 4 will be taken on the right side. That becomes 4 by 13. Okay, so also we can say that multiplying both sides by 4 by 13. So that will give you 4 by 13 times e raised to 2x by 2 cos 3x plus 3 by 2 sine 3x, and this will also be multiplied by 4 by 13 c. Also to make this a little bit different, we can take c1, so that will be 4 by 13 c1. This will get cancelled by 2 times, so 2 e raised to 2x upon 13 cos 3x plus 3 by 2 sine 3x, and this will can be substituted as c, where we will write c is equal to 4 by 13 c1. This is how we have calculated this first integral by using the by parts formula. Okay, this was the same formula that we have studied and we have applied it here. I hope you are comfortable with this problem. If you have any doubt, just let me know in the comments. Also, still, if you haven't subscribed it yet, please do a subscription here, and also check out my playlist where most of the topics from the 11th as well as the 12th standard has been taught. Okay, now let's move on to the next question, that is I is equal to, so here we have the integration x multiplied by sine inverse. Now if you just check it out here, this is your algebraic function, this is your inverse trigonometric function. If you follow the LIATE, inverse come first and algebraic comes later. Okay, so in that case you have to take this as u and this as v. Okay, so u is your first function, v is your second function, so we'll apply it here. So I'll just write u first multiplied by v. Okay, you can skip this step if you know already. Okay, now we'll apply the by parts formula, keeping u aside. Then integration of v dx minus integration, then you have to take the derivative of u, then again the integration of v, bracket close, and the dx. Okay, then this sine inverse x will remain as it is. Integration of x to the power 1 will be x to the power 2 upon 2 minus this integration, and the derivative of sine inverse will be 1 upon square root of 1 minus x square. Again we have the integration of x, so the answer will be same, x square upon 2 dx. Okay, so this can be written as x square sine inverse of x upon 2 minus, and this is the integration that you have to do. We'll keep the 2 outside, dx. Okay, so now this we have to perform. So for this, what we can do, we'll take the minus sign inside. This minus sign will take it inside, so I'll keep the minus sign inside, and here I'll take plus. Okay, after that I'll write this again. I'll take plus 1, close the bracket, and then minus 1. We have to create the same term as that in the denominator. Okay, because we have the same power. Okay, so what will this give you is I is equal to again x square sine inverse of x upon 2 minus, okay, not minus, it is a plus. Okay, then we have the 1 by 2 outside, integration. So we'll separate this two integration that we have, 1 minus x square minus 1 upon the square root of 1 minus x square. So that gives you 1 minus x square upon square root of 1 minus x square, then minus 1 upon square root of 1 minus x square dx. Okay, so again this will be repeated then 1 by 2. Then what we can do, we can just integrate to both of this. Okay, so we have to take the formula for this. Now for this, 1 minus x square upon square root of 1 minus x square will give you square root of 1 minus x square. Okay, and here I'll write dx here, minus integration of 1 upon square root of 1 minus x square dx. That 1 by 2 will be multiplied to both of this. Okay, that will be same. I'll copy this later. So integration of square root of 1 minus x square. Now we have the formula for this. Okay, I'll tell you, but let me just apply the formula, that is x by 2 square root of 1 minus x square plus 1 by 2 sine inverse of x. This is the formula, and this is your sine inverse of x. Close the bracket. Okay, now I'll tell you the formula. What formula did we apply here? So we have applied the two formulas. First, integration of 1 upon a square minus x square, that is nothing but sine inverse of x upon a. Okay, this is your first formula. And the another formula here is integration of a square minus x square is equal to x by 2 integration of a square minus x square plus a square by 2 sine inverse x by a. This is the formula that we applied here. Okay, you can take a note of this. Okay, so I'll just rub this out because I have to complete this sum now. Okay, so the formula has been applied. I'll copy this, x square sine inverse of x upon 2, and here it will be plus c since we have completed it. Okay, again this x square sine inverse of x upon 2 will multiply this 1 by 2 to both of this, that gives you x by 4 square root of 1 minus x square, and this will be 1 by 4 sine inverse of x minus 1 by 2 sine inverse of x. Not a bracket here, plus c. So we can solve this 1 by 4 sine inverse minus 1 by 2 sine inverse. Okay, so that gives you 1 by 2 sine inverse of x plus c, and we'll copy the rest of this. So this is your I that we have got, that is x square by 2 sine inverse of x plus 1 by 4 x square root 1 minus x square minus, and this will be I think this will be 1 by 2, not 1 by 2, it will be negative 1 by 4, negative 1 by 4 sine inverse of x plus c. Okay, so this is how we have solved the second problem. Hope you understood this. Now let's just move on to the next one, which is third, I is equal to. So I'm taking the third problem, which is a similar way, and also it is having one more part of the integration, that is having the substitution. Okay, so we are going to do the substitution as well as the integration by parts in the same sum. So integration sine theta log of cos theta d theta. Okay, so if you can see here, we are having two terms which are getting multiplied, but do not start directly with the by parts formula. First look out for the substitution. Whenever it is given as a complicated function, look out for the substitution that you can do. Substitution brings your integration question to a simpler form. Okay, so here what we can do, we will substitute cos theta, let's say t. So the derivative of cos is negative sine theta d theta dt. Negative can be taken on the right side, so that becomes negative d. Okay, so now your question reduces to minus dt Okay, the sine theta and d theta can be replaced with negative dt, and this becomes log of t. Okay, you can take the minus outside, so that gives you log t dt. Okay, now we have the integration of log dt. But if you can remember the second rule that I've told you, that whenever it is been given with the log as well as the inverse and the second function is not given, so in that case you have to consider the second function. You have to consider the second function as 1, v, and take this function as u. Okay, now solve it. So keep this minus sign aside. Okay, we'll keep this aside and we'll apply the by parts formula. So keeping u as it is, then the integration of 1 dx minus integration derivative of log t. Okay, here it is dt. Okay, now again integration of 1 dt, close the bracket, then dt, then again close the bracket. So if you can just solve this, log t will be as it is, and the integration of 1 dt will be t minus, again integration, derivative of log t will be 1 by t, and the integration of 1 with respect to t will be t. Okay, dt, and we'll close the bracket. I'll solve it here. So negative, again log t multiplied by t minus this t and t will get cancelled. Now the integration of 1 dt will be again t. Now the integration part is completed. We can write plus c. You can take the minus inside, so that will give you t minus log t plus c as I. Okay, so I'll write the final answer here. So I is equal to t minus, also we have the t here, so t minus t log t plus c. So taking t common, we'll write 1 minus log t plus c. Now we can resubstitute, that is cos theta 1 minus log cos theta plus c. So this is your final answer that we have got. Okay, hope you have understood integration by parts. Okay, and then these three examples I have taken from your standard textbook. Okay, if you haven't understood this or any of this step, you can mention me in the comments. I'll reply to you. Okay, and also if you want more video on this integration by parts, just let me know in the comments. Okay, thanks for watching, and if you haven't did the subscription yet, please do subscribe my channel and share it with your friends. Thank you so much.